We open the Alien Encounter world. And here we have the spider robot moving forward 1 meter after he turns to face the alien on wheels. Well, maybe 1 meter doesn't work well because, for example, my objects could be moving during the execution of my movie, and I don't know how far apart they are at the time this line of code is executed. So guessing at 1 meter is really not a good way to do it. It's fine for the exercise we did, but we need to learn a little more. So what I'm going to do instead is, where this says 1 meter, I'm going to take the distance between the spider robot and the rock. And in order to do that, I'll click Functions and Proximity. I have several different kinds of functions here. Let's take a quick look at them. And I'll minus all these out so we can get them all on the screen here. We have Proximity, which shows where things are in relation to my spider robot, size, spatial relation, point of view, and other. And right now I want a proximity function. So I'm going to move the spider robot distance to rock 3. And I'm going to drop that right on top of where the 1 meter is and pick rock 3. And so now my line of code says spider robot move forward distance to rock 3 and hit play. And you can see my spider robot went right inside my rock. Well, when Alice calculates the distances between objects, it calculates the distance from one center to another. And so we have a collision here. Sometimes we want a collision, sometimes we don't. In this case, we don't. We don't want a robot walking right through a rock. So we've got to figure out a way to get the spider robot to walk up to the rock without actually going through it. And that's what we're going to do now. Let's get that off of there. Now, where it says distance to rock 3, between rock 3 and more, there's 2 little triangles we can click on. Click on the second one and pick Math and distance to rock 3 minus. We have to reduce that distance somehow. It gives us a few options here. None of them are very good, but we're going to pick one as a placeholder and then alter the placeholder. So move distance to rock 3 minus 1. And then we're going to, where that 1 is, I need my rock 3 here. And yours probably isn't called rock 3. It might be called rock. It might be called rock 2. Who knows? You've got to pick the right one. I want the rock's width, so I've got to enlarge my size list here, and where it says 1, I'm going to put rock's width here, drop that on there, and this is the way the textbook suggests that we do this. And so let's see how that works out. And while it worked for the people who wrote the textbook, it didn't work for me. Evidently my rock is too big, and you can see my spider robot actually moved away from the rock. So I'm going to have to modify this a little bit to make it better, and it's quite useful the way I'm going to do it. So I'm going to take a moment to explain what it is that I'm doing. Okay, take a look at this expression here. This is the idea that I want to create in Alice, and I put it here to make it a little easier to understand without all the little icons Alice adds in. What I want to do is take the distance to the rock, and I want to subtract half of the robot's width, so that I get remove the distance between the center and the edge of the robot, and I want to subtract half of the rock's width. So I'm going to take distance to rock minus the sum of the robot width divided by 2 and the rock width divided by 2. And that will give me the distance between the edge of the rock and the edge of the robot. Now let's go put that idea into Alice. Okay, so I've got minus rock 3's width, then click on this little triangle here and say Math, rock 3's width divided by 2. and then I want to add something to that, math plus, and what I want to add to that is the the robot width divided by 2, but that's not on here, so I'm going to put a 1 in there as a placeholder, and then I've got to come up here and pick my spider robot, and then my spider robot's width, drop that on the 1, and then divide that by 2, math divided by 2, and I think that ought to do it. Let's see what happens when we play the world. And notice now the robot goes right up to the rock, his leg is right up next to it, but there is no collision. So that's the way we want to do that. And we have one more thing to look at, and that is a control statement that gives us a great deal of control in a program where we test a condition, and if the condition is true, we do one thing. If the condition is false, we do something else. It's called an if-then-else statement, and they are used very, very frequently in computer programming. And so what we want to do here, well, let's play the world, and I'll show you where we've got a little bit place for improvement. The robot comes over to see the alien. The alien hides. The robot would like to look at the alien, but the rock may be taller than the robot. And it certainly looks like in this case the rock is taller, so the robot can't see him. So let's insert a statement here. And down in these tiles, we've done the do in orders, the do togethers. I showed you a loop in the rabbit code. Let's take an if then else. Oops, got to get rid of my world first. We'll take an if then else and say if the spider robot, no, just say if true to start with. So it says if true, do nothing, else do nothing. So we have our structure in place. And now we need to insert our statements. So we have functions selected for spider robot. If spider robot is shorter than, so drag that up to where it says true. So it now says if spider robot is shorter than, and I'll pick rock 3 out of my pick list. Then what I want to do is expand spider robot here. I'm going to make his head fly up in the air. So I'm going to pick neck, and then methods, then move, neck move. You know what, before I do that, I need to put a do in order block there. So underneath my if statement where it says do nothing, I'm going to put a do in order block. Then I'm going to say neck move up 1 meter. I think I want to move it more than a meter, and you may have to play with yours to figure out how far you want it to move. And if you really wanted to get fancy, you could move it up the distance, the difference between the height of the rock and the height of the spider robot, like we did with the widths a little bit ago. But I'm just going to tell it to move up 1.5 meters. Okay, now I want it to move up 1.5 meters, but I also want it to come back down. So you know what, before I do that, I think I'm going to give it a duration. So I'll give it a duration of ½ a second, and then I'm going to right click on the edge of this tile and say make a copy, and then it makes it an exact copy of that line of code right underneath. I'm just going to change the up to down so it moves back where it was. Now hit play. And the head goes up, comes back down, and everything's looking good. Okay, do those things. You don't have to do everything exactly as I did it as far as the demos in the beginning. You can just take a copy of your alien world and do some things with the centers and the point ats and the move tos, and just practice those things a little bit, but you don't have to do it exactly the way I did it. And that's it for today's homework.